Our solar system began as a vast cloud of gas and dust. This cloud drifted through space for countless years. It was a quiet time, nothing much happened. But then something stirred. Perhaps a passing star sent ripples through the cloud, or maybe a shockwave from a distant supernova disturbed its delicate balance. Whatever the cause, the cloud began to collapse. Gravity pulled the gas and dust inwards. This marked the beginning of our solar system's incredible journey. As the cloud collapsed, it began to spin. The spinning motion caused the material at the center to heat up. The temperature at the core became incredibly hot, millions of degrees. This hot, dense core would eventually become our sun. The more the cloud contracted, the faster it spun. Think about an ice skater pulling their arms in during a spin. This is similar to what happened with our solar system. The faster rotation flattened the cloud into a swirling disk of gas and dust. At the center of this disk, our sun was born. While the sun was forming at the center, the rest of the disk was not idle. The material in the disk started to clump together. This clumping was due to static electricity and gravity. Tiny particles stuck together, forming larger and larger bodies. Over millions of years, these clumps grew into objects called planetesimals. Planetesimals were like giant boulders, some as big as mountains. They were the building blocks of planets. They moved around the sun in roughly circular paths, but sometimes their paths crossed. When planetesimals collided, they didn't always smash apart. Sometimes they stuck together. This process, called accretion, is how planets grew. Imagine dropping marbles into a bowl of honey. They would stick together and gradually form a bigger clump. In the region where Earth formed, the planetesimals were mostly rock and metal. Over millions of years, these planetesimals crashed into each other and fused together. A large, hot, molten ball of rock and metal emerged. This was the birth of Proto-Earth. Section 5. The Moon's violent birth. Early in its life, Proto-Earth experienced a cataclysmic event. A Mars-sized object named Theia slammed into our young planet. The impact was colossal. Molten rock was blasted into space. Some of this material fell back to Earth, but a significant portion remained in orbit. Over time, this orbiting debris coalesced under its own gravity. It eventually formed the Moon, our constant companion in space. Section 6. A crust forms. The early Earth was a hellish place. Its surface was a molten ocean of magma, but over time things began to cool down. The outer layer of molten rock slowly solidified. This formed the Earth's first crust. The early crust was constantly bombarded by asteroids and comets. This bombardment made the surface extremely unstable. Volcanoes erupted frequently, spewing lava and gases into the atmosphere. It was a time of intense geological activity. Section 7. Volcanoes and the early atmosphere. Volcanoes played a crucial role in shaping the early Earth. They released gases from the planet's interior, forming the early atmosphere. This early atmosphere was very different from the air we breathe today. It was thick with carbon dioxide, nitrogen, water vapor, and other gases. There was very little oxygen. This early atmosphere was hostile to life as we know it. But it set the stage for the next chapter in Earth's story. Section 8. Water's arrival. Water is essential for life as we know it, but where did Earth's water come from? The answer lies partly in those early volcanoes. They released vast amounts of water vapor into the atmosphere, but that's not the whole story. Scientists believe that a significant portion of Earth's water arrived from space. Icy comets and asteroids, remnants from the solar system's formation, bombarded the young planet. These impacts delivered vast quantities of water ice. Section 9. Life begins. Over millions of years, Earth continued to cool. The water vapor in the atmosphere condensed and fell as rain. This rain filled the low-lying areas, forming the first oceans. The oceans were teeming with dissolved minerals and gases from the atmosphere. In these warm, nutrient-rich waters, life emerged. Simple, single-celled organisms appeared. These early life forms were unlike anything alive today. They thrived in the harsh conditions of the early Earth, and they played a crucial role in transforming the planet. Through photosynthesis, they began to release oxygen into the atmosphere. This oxygen would eventually pave the way for the evolution of more complex life forms, including us.